Today our goal is to take those empirical formulas we learned how to calculate on Friday, which was not really hard but tedious. Okay? Now we want to be able to turn them into the actual molecular formula. How do we tell the difference between CO2 and C2O4? Okay? Well, the empirical formula is the lowest ratio, right? So the molecular formula is either the same or some multiple of it, right? So it's either the same, or it's going to be twice as heavy, or it's going to be 3 times as heavy, or it's going to be 4 times as heavy. The real molecule has to weigh what the lowest ratio weighs, or it has to weigh more. Because if it's the lowest ratio, the real thing weighs that much or more. Seem reasonable? So the lowest ratio is the lowest it could weigh. And if it weighs more, it's not going to weigh an arbitrary amount more, because you have to add whole atoms. So you'll have twice as many of everything, or 3 times as many of everything. And that would mean it would be twice as heavy, or 3 times as heavy. It will be a whole number of times heavier. Not a whole number ratio, a whole number multiple. It can't be 1.5 times as heavy, because that means you'd have to have half an atom someplace along the way. And we're not that good yet. Well, we never will be. Because if you had half an atom, it wouldn't be the atom you thought it was. Okay. So all we need to know is how much heavier the real molecule is than the lowest ratio. So you can divide the actual molar mass by the mass of 1 mole of the empirical formula. We're going to call it the empirical formula mass, the mass of 1 mole of the empirical formula. Get rid of that second the. So if you take the actual molar mass and divide it by the empirical formula's molar mass, you will get a whole number. It'll be the same, so the number will be 1. Or it'll be twice as heavy, so it'll be 2. And if it's twice as heavy, the reason why it's twice as heavy is because it's got twice as much of everything. So the difference between CO2 and C2O4 was the CO2 weighed 44 grams for 1 mole. The C2O4 weighed 88 grams for 1 mole. It was twice as heavy because it had twice as much of everything. So what added piece of information do we need? What we need is the actual molar mass. So they have to give you more information. They got to tell you how heavy 1 mole really is, or give you enough information to figure it out. Okay. Compound has an empirical formula of ClCH2 and a molar mass of 98.96 grams per mole. What is its molecular formula? Well, I've got a Cl, a C, and 2 H's. The Cl is 35.45 grams. The C is 12.01 grams. And the 2H is going to be 2.02 grams. I guess these aren't times anymore. Let's get to the multiplication. But okay. Add that up, that's 7, 4, 9, 4, 49.47 grams. So I added up what the empirical formula would weigh, 1 mole of it. Then I take the actual molar mass, 98.96 grams for each mole. and divide it by that lowest ratio. By the way, it's 49.48. 49.48 grams. And if you push that in your calculator, you'll get exactly 2. What does that 2 mean? That 2 means the real molecule is twice as heavy. Why would it be twice as heavy? It would have twice as much of everything. So instead of having 1 Cl, it would have 2. Instead of having 1 carbon, it would have 2. And instead of having 2 hydrogens, it will have 4. If I've got twice as much of everything, I'll get the same percentages. I'll get the same empirical formula. The only difference is it'll be twice as heavy. So if you know the molar mass, it makes sense that this is a pretty logical thing. Just figure out how many times heavier it's got to be. Because it's got to be a whole number heavier because atoms are whole. Okay? So compound has an empirical formula of CH2O and a molar mass of 180. What's its molecular formula? Work that one out and see what you get. And you'll see it's a really sweet answer. How sweet it is. Oh, you can do the division in your head. Calculator dependent. 12 plus 2 is 14, plus 16 is 30. Okay, so you should have gotten the empirical formula mass was 30.01 grams. The real thing weighed 180 grams. 180 divided by 30 is the same as 18 divided by 3, which is 6. So it's 6 times as big. So your answer should have been C6H12O6. Sweet, because it's glucose. It's sweet. It's a sweet answer. Dude, sweet. Okay, but where the heck are we going to get ClCH2? Well, we're going to get that from tearing it apart into pieces. Does that make sense? So we're really not going to start with the empirical formula. We're going to start with percentages. So we're probably thinking that what you got to do is take those percents, turn the percents into grams. By assuming 100 grams. Okay? Then turn the grams into moles, and then do a ratio, and you'll get the empirical formula. Then you can do this process. And that will work. Okay? It will work. You can do everything you did for homework last night, and then add this to it. Not that much harder. But there's actually a shorter way. Okay? And it's got to do with picking the amount. Okay? What you want to pick as the amount is the actual molar mass. Okay? And you want to multiply the percent times the actual molar mass. Because if you've got something that's 25% carbon, right? and you know that you've got 50 grams of it, right? You know 25% of 50 is just over 12, or just, yeah, 50 over 12 is just over 4. So you'll have about 4 grams of carbon there. Yeah. But if I multiply by the actual molar mass, I'm going to find the grams of carbon in a mole of this stuff. It's going to give you the mass in 1 mole of the compound, the number of grams in 1 mole of the compound. If you take those grams and turn them into moles, you will always get whole numbers. Not whole number ratios, whole numbers. You will get a 2 or a 3, because in a mole of a compound, there can't be 1.67 moles of an element. There can't be a fraction of a mole of an element in a mole of the compound. Does that make sense? So since I picked my amount to be 1 mole, I'm going to get whole numbers of moles for all the pieces. Those are the subscripts. You're done. So on Friday, we did caffeine. And we found the empirical formula of caffeine. So now I'm going to add the molar mass to it. It's 194 grams. So you can do what we did on Friday. We found the empirical formula for this on Friday. And you can figure out how heavy that empirical formula is. And then divide the 194 by that empirical formula. It'll tell you how many times to multiply. You'll get the same answer. If you've already done the percent part of it, there's no sense starting over and doing the molar mass. But if you haven't, then you got some work to do. So here we go. So the real molar mass is 194 grams. Times 0.4948% carbon, right? Move the decimal place over, multiply. So 194 times 0.4948 equals 96.0 grams of carbon. 1 mole of carbon weighs 12.01 grams. If you divide that by 12, you get 6. Or you get 8, sorry, 8. So the real formula is C8. Then I take the 194 grams times 0.0515. Are we okay with why I moved that, put that 0 in? You got to move it twice. So 0.0515 times 194 is 9.99 grams of H. And with 1 mole, 1.01 grams of H, being 1 mole of H, do you need a calculator to figure out what whole number you're going to get here? 9.99 divided by 1.01. What's the whole number you'll get? Should be. It's going to come out really close to 10. H10. 28.87% nitrogen, so 194 grams times 0.2887 equals I just type 56.0 grams of nitrogen, and grams of nitrogen to moles of nitrogen. 1 mole is 14.01, and we can all see that that's 4. And then finally 16.49%, so 194 grams times 0.1649 equals 32.0 grams of O, 16.00 grams of O for 1 mole of O, 2 moles of O. So I got N4O2. And if you go back for Friday to check what the math we did with that, when we did the empirical formula for this, we got C4H5N2O. Okay? It's got twice as much of everything. So sometimes being able to pick the amount can make your life a little easier. Right? Seem reasonable? Hey, I don't want to cause you any headaches. But if you had a headache, ibuprofen is 75.69% carbon, 8.8% hydrogen, 15.51% oxygen, and has a molar mass of about 207. What's its molecular formula? So taking the grams, multiplying by the percents as decimals, found out the grams of each element. So in my 207 grams, 157 of them will be carbon, 18.2 will be hydrogen, and 32.1 will be oxygen. Those add up to 207. Okay. And that means it's 13 moles of carbon, 18 moles of hydrogen, and 2 moles of oxygen. So in 1 mole of stuff, there's 13 moles of carbon, which means it must be C13. In 1 mole of stuff, there's 18 moles of hydrogen, so there must be H18. And in 1 mole of oxygen, it would be O2. What would the empirical formula for this be? This is the empirical formula. Because the 13's odd and the 2's even. Can't do anything about that. Okay. Extra super duper hard? No. And hopefully the steps make sense because we're just trying to find out what's there. So the way to get good at this is to ask the teacher. No. Practice. So but I'd not bring my book, Mr. Green.